First of all, thank you very much for the opportunity to talk to you. I get to meet the Angus board roughly once a year or so, and I enjoy the interaction, and I know there's some other people here today, and I hope that what I've got to go through is helpful and clear, helps you understand the technical work that's behind the enhancements to Breedplan for Angus that have been introduced recently, and I'm sure we're going to identify some things that are still to be worked through, both from a technical perspective and also more broadly, and I'll do my best to contribute to whatever that discussion might be. I am going to concentrate on the technical work that AGBU did, basically because that's what I was asked to do, so I will do it. But if there are questions that go more broadly than that, and I think I've got something useful and accurate that I can contribute, I'm happy to do so. So I'm going to talk about Angus Group Breedplan, the recent enhancements and some future developments. I really want to stress this is work that's been done by the AGBU team over the last year, 18 months or so ago. I'm very much a Johnny-come-lately in that regard. I've just been the director for 12 months now. And Gilbert, who's here, and David Johnson, who could not be here today, I'm afraid, were heavily involved in the actual scientific work that I'll be talking about. So thank you very much to Gilbert and David. The topics I'm going to try and cover, first of all, what's been changed and why in the Angus analysis. Then I want to look at some of the changes that you will have seen in the EBVs and the indexes, and provide some simple explanation for the reasons behind the sorts of changes you're seeing. Then finish off with a couple of brief slides about current and planned developments, and very simple summary. So the main bulk of it has been what's the work that we did and what's it mean in terms of now that's been implemented in Angus Breedplan. So starting off with the first part, and as I said, if you want to ask questions along the way, as long as it doesn't get into really long discussions, I think that's probably simpler, because some of the topics, it would make sense to address at the time. So I want to start by just reminding you of the point about the whole purpose of Breedplan is to describe the genetic differences we know exist in cattle, and to do that accurately. That's what EBVs are for. They're simply descriptors of the genetic merit of animals. They're based obviously on performance, pedigree, etc., but they're there to try to describe as accurately as possible genetic differences between cattle. And one of the things that's important in making sure the EBVs and the indexes are accurate is that you've got what are called genetic parameters are estimated, and they're up to date. And the simplest example of a genetic parameter, and you may have heard this before, but is the heritability of a trait, which is essentially how much of the superiority of parents is passed on to progeny. It's important to know that proportion, how much of that superiority is passed on, because that helps us to use information from animals that are related to each other to improve our estimate of each individual animal's genetic merit. That's the whole point of what we're trying to do, to work out how good is each individual animal. Knowing the heritability helps us to know how much to take account of that animal's performance and the performance of its relatives. So it might sound like jargon. It is jargon when we say genetic parameter estimates, but they're absolutely essential for Breedplan to be producing accurate EBVs and index values. And so that's why the work needs to be done at regular intervals to make sure those parameters are as accurate as we can possibly make it. Now, the last time there was a major review of Angus genetic parameters was back in the year 2000, which is whatever it is, 14 years ago. And the estimates at that time were based on Angus cattle data from previous years, so there was a good lot of data then. The estimates were quite sound and a good basis for producing EBVs, but there's been a lot of new data come in the last 10 or 15 years, or 10 or 12 years, at least 500,000 animals have been recorded and entered the Angus database in the period since 2000, and there's some possibility that the relationships between traits have changed a bit over time, so we need to know that. And the other thing is that your breed has made significant genetic change in lots of traits. You know, the cattle are growing faster, there's more marbling, etc., etc. And when there's genetic change, you need to check the parameters to make sure that they're still in line with what you think they are. And so those two reasons mean it was timely to re-estimate all the parameters in the Angus breed somewhere around last year, the year before, which is, as it turns out, when it was done. So just want to stress, the reason for the work is to make sure that the EBVs that you get out of Breedplan are as accurate a guide to animals' genetic merit as we can make them, and we need accurate parameters to do that. And the reason to review the parameters is because there's been a lot of new data and a lot of genetic change in the Angus breed over the last 10, 12 years. So we need to check that the estimates that we're using, the heritabilities, the correlations, are what we think they are, and if they're not, to revise them. And so the work that was done was based on Australian Angus data, and to give you some idea of the sorts of numbers of records that are being analysed, depending on what trait, you can see ranges there, but for growth records, it's somewhere between 80,000 and 300,000 records were used in the analysis to work out the genetic parameters. And those were records collected in the period 2000 to 2012 or so. Scan records is, roughly speaking, 75,000. That's live fat, live muscle, etc. Depending on what trait it is, between 60 and 100 and whatever it is, 75,000 reproduction records. So a lot of data there. And very significantly, and we'll be coming back to this obviously, there's a lot of new carcass data that's come in, so direct measurements on carcasses of Angus cattle or Angus cross cattle. Now, those numbers, from the perspective of estimating genetic parameters, which is what we've set out to do, those numbers are really, really healthy. You've got lots and lots of data with which to estimate the heritabilities and genetic correlations and so forth. Angus is in a very, very good position from that perspective because there's enough data to estimate essentially all the parameters that for the traits that you're currently working with, and to do so with high confidence. So we're not sort of scrabbling around to find enough data to do some work with. There's a lot of good data there, and that's what's been used in the work that was done. So just going on a little bit, the work that Gilbert and the team did included estimating parameters for something like 26 traits, including some that had previously been kind of in a research category, which meant that they weren't full-blown Breedplan traits. There might have been limited amounts of records. I think the NFI traits are an example of that. So they hadn't been fully introduced to Breedplan. There was a modest amount of data, and that was being used to underpin the parameter estimates that were previously being used. There's now more data, and so we can estimate the parameters with more confidence than we had previously. In general, everything has changed a bit. I don't think I'm sure this is not quite true, but most traits there would have been a change, either in the heritability or one or more of its genetic correlations. But in the main, we're not talking about big changes. To give you an idea, the heritability of scan fat, I think, is 31%. Well, I think it was 32% before. So we're not talking about big radical changes in the main. Now, I think that's important to keep in mind, because it means that by and large, the EBVs that you've been getting in the past were a reliable guide to animals' genetic merit. The parameters that were being used previously in Angus Breedplan were more than in the right ballpark. They were close to what we've come up with in the new estimates. So in general, the genetics of the traits has remained roughly what we thought it was. We can be completely confident now that with the more recent data, and lots of it, that the parameter estimates are good, solid estimates. I'm going to concentrate a little bit more on talking about some of the traits where there have been some bigger changes. I think some of those have already been flagged in some of the communications that's gone out, but I'm not going to be going through table after table of old versus new parameters and showing you reams and reams of numbers. I want to pick out some key points. The other point to make is this is not so much an analysis, sort of technical analysis question, but one of the things that has been done is to change the base so that in the reporting the EBVs are compared to a base year, and the base year is now 2005 as I understand it, whereas previously it was 2000.
Yeah, somewhat depended on the trait.
Yeah. So one of the things, I'm not going to spend a lot of time on base change, but base changes is part of the reason for animals' EBVs or indexes changing, but I'll talk a little bit more about that later. But that's different from estimating genetic parameters. And the other thing I will touch on briefly is the fact that in genomic tests information can now be routinely incorporated into Breedplan, but that's not the focus of my what I'm going to cover. So really what I'm going to concentrate on is what changes have we seen in genetic parameters, and what sorts of effects would you see in bulls and cows' EBVs, and how animals compare. That's the outcome of really checking the nitty-gritty of the genetic parameters of the Angus breed that are used in Breedplan. The reason for doing it is because it's been quite a while since the last one, and it's really good idea to check that things are still as we think, and there's been a lot of data to underpin the analysis. It gives us great basis for confidence that the estimates that we're using now are sound. No questions? So you'll have to bear with me because I tend to do rather boring slides, which means you can read them all, and I'm going to kind of work through what I've got on the screen. So if you want to read it, that's fine. This is not a presentation with lots of pictures of bulls or anything like this. I want to go through the things that where we've found changes that you might be interested in and might be important. Most of it's in words. I apologise for that if you like lots of pictures, but perhaps I'm not very imaginative. So bear with me. I press the thing in the middle for the red. Yep. So all I'm really going to do is work through 3 or 4 trait groups and tell you a little bit about what we found out about the genetic parameters. So I can assure you this is going to be fairly dry. If you're kind of looking forward to excitement, this is going to be dry, steady stuff, but that's how I've got to do it. So I'm going to go through each group of traits, there it is, talk a little bit about what we found in the work that we've done and why we found the change. If there's a reason for why things are different, I've tried to explain it, and then I'll go on and talk a little bit about, okay, we see a particular change, what effect might you see in the bulls or cows in the results of Angus Breedplan? So that's the approach I'll be taking for the next few minutes. The first group of traits I'll touch on is the weight traits, so it's birth weight, 200 day, 400 day, 600 mature cow. And what we found is that, first of all, the genetic range, I've called it scale there, by which I mean how widely spread animals are genetically. The scales are all, there it is, pretty much what we thought they were. So the genetic range between the top and the bottom within a year is roughly speaking what we already thought it was. We have found that the maternal genetic effect is a bit bigger than was previously thought, particularly for birth weight and weaning weight. So the effect of the mum's genes on calves' performance early in their life, birth weight and weaning weight, was a bit bigger than had previously been estimated. Now, I suspect the reason for that is simply that there's a lot more data where the recording of the calf has got the mum and the maternal grandsire associated with it. So I think that's what it is. I think it's unlikely that the size of the maternal genetic effect these days is bigger than it used to be. I think we simply now have more data to estimate that effect more accurately. So that's the first thing. Weight traits in general, there haven't been significant changes to the heritabilities and by and large to the genetic correlations, the relationships between weight traits. Now if we go to the scan traits, which is the live fat, live muscle and IMF, heifer fat, so the genetic range in fatness in heifers is a little bit smaller than we thought it was. I'll get on to reasons for these in a moment, but there's a slight reduction in the range that you'd see. In bulls, there's been a significant reduction in both the observed range of fat, from fat through to lean, and also in the underlying genetic range. So animals are actually genetically more similar to each other. There's less spread in the genetics for fatness, live fat in bulls than was previously the case. Actually, it'd be better if I talked about the reason as I went down this table. I suspect the heifer fat range becoming a little bit smaller is simply because cattle have been selected to be a little bit leaner. It's not a big effect, but there's been some selection against subcutaneous fat in Angus cattle. Some of that's reflected in heifers, and so there's a slightly smaller range genetically in their fatness than there was previously. The bull effect, the reduction in both the observed and the genetic range in bulls is, I think, probably due to two factors coming together. One is people are scanning bulls a bit earlier than they used to, a bit younger, so they're not as developed as they used to be, and also the cattle are generally becoming a little bit later maturing. That's partly why there's some reduction in fatness in the heifers, and I think there's the same or possibly a bit more observed in the bulls. So there's less range now in the EBVs for live fat in bulls than there was previously in Angus cattle. And as I said, I think that's a combination of some of this is a selection effect. The cattle have generally become a little bit leaner, and some of it I think is because bulls are being scanned slightly earlier in their life than they previously were. Heifer eye muscle, no change. This one puzzles me a little bit. The bull eye muscle, we've seen a slight reduction in the range both in observed and also genetically, and I think that must be primarily because the bulls are being scanned earlier, younger in their life than they used to be, coupled probably with this maturing effect. That's what I think must be the explanation. Well, I think you highlight a significant part of it is people scanning, particularly bulls, younger than they used to, and that does cause some problems with some of them being too lean to scan, in fact.
And it's added cost to try and bring them up to that.
Yep. Now, the last point in this is heifer and bull IMF. So again, Bob, this is IMF based from the scan, and interestingly, we've seen an increase for both heifers and bulls in both the observed range and the genetic range for that, and that can only be because people have been selecting cattle to have more marbling, and it's starting to be expressed at whatever age people are scanning their cattle, and so that there is simply a result of selection to increase the marbling in Angus cattle. So that's the weight and the scan traits. Now let me go on and talk about the other two groups, reproduction and carcass. And there's been a significant learning in the reproduction traits, but I'll just go through these stepwise. So starting with gestation length, where is the thing? The observed scale that the range between long gestation and short gestation is pretty much the same as it always was, but we know that the heritability, how much of that is genetic, is much, much more than was previously thought. And the increase in heritability is really, really substantial, from 21% to 65%. So that's like saying, if this was the range, instead of only 20% of it being due to genetic differences, just on 2/3 of it is actually genetic differences. So it's saying that gestation length is actually profoundly, powerfully influenced by genetic differences, much, much more than was previously thought. And my conclusion is that the reason for this finding is just a lot more data about gestation length. I'm sure that must be the reason. And that has significant consequences, which I'll come back to in a moment, because gestation length is related to some other reproduction traits that you see reported. Scrotal, very little change in that at all, in either the observed range or the genetic range, so it's essentially unchanged. And days to calving is also unchanged. So no genetic or phenotypic range changes there. Gestation length, significant change. The question was, with this change that I talked about here, the genetic range and gestation length, has there been any change in correlations between this and other traits? And the answer is yes. Now, I haven't pulled out the highlight points about genetic correlations. I should follow up with that. But one of them is between genetic gestation length and calving difficulty, and that's certainly had some impact. And we'll follow up with that afterwards. I'm afraid I don't have a slide about that. Let me now just go on to the carcass traits. And so this is important for a couple of reasons. Firstly, it's because it's the traits that are actually predicted that feed into the index. So the EBVs for marbling that are used actually relate to carcass marbling. We're trying to work out animals' genetics for marbling in the carcass, not the scan marbling. Scan marbling is like a clue. It's telling us something about carcass marbling, but carcass marbling is the thing we're really interested in, because that's basically what has some impact on price. These traits are carcass weight, carcass P8 fat, carcass rib fat, carcass eye muscle area, carcass retail beef yield, and carcass IMF. And the first thing we found there is that the heritabilities of all of them with the new data analysis, they're all very similar to what was previously estimated and used in the Angus analysis. The previous estimates, a lot of it was coming from CRC data, but now there's a substantial amount of actual new Angus carcass data that's come in, and that first of all tells us that the heritabilities of those traits, sizes, genetic differences, are very similar to what we thought they were before. For these four traits, weight, carcass weight, P8, eye muscle area, and intramuscular fat, marbling in other words, however, the scale has increased. The range has got bigger. We're seeing bigger, what are called phenotypic differences, the actual differences you observe. That range has gone up, and because the heritability is still the same, it means the genetic range has gone up. So you're going to see a bigger spread of EBVs for these four traits than used to be the case. And it's by anywhere between 10 and 30% bigger range. So animals that had the same data before and for these traits, their spread will have got bigger. So the tops will be further out, the bottoms will be further down. And that's largely a consequence of the fact that they're being measured at a higher weight than was the case before. The carcass data that's come in, this gets back to your point, Bob, most of the data that's come in, or virtually all of it, is up around the 400 kilo weight rather than the 300 kilo weight, which is where the CRC data was collected. And that's why this scale has expanded out. The genetics is the same as it always was, that's the heritability bit, and I'll touch a bit more on this in a minute, but the scale has been spread out because essentially it's being measured on a larger carcass. Okay, now let's just look at some of what sort of things you might see in your reports and in the cattle as a result of all that. First of all, with the weight traits, in general, you're not going to see much change in animals' EBVs because the ranges and the heritabilities are similar, and the genetic trends are virtually unchanged from what they were before, and I'll show you those in a minute. So no real change in the weight traits in that regard. The differences between animals born, say, this year and 5 years ago will be pretty much exactly the same as they were before. That's just another way of saying that the genetic trend is virtually unchanged. And I'll show you this in a minute, but this holds also for mature cow weight. The genetic trend for mature cow weight is exactly what it was before. So weight traits have essentially, in general, unchanged themselves from what was there before. And that probably, more than anything else, reflects the fact that that's the group of traits for which the breed had the most data pre-2000. So there was heaps and heaps of data before, and the new data hasn't changed the story very much. The scan traits, so remember this is live fat, muscle and IMF, really very little change. There's been a little bit of spread out in the genetic trend for the fat traits. The trends are a little bit bigger than we thought they were, but relatively little change. I'll come back to this point about this correlation between scan and carcass marbling in a moment, because it's quite important in relation to that carcass weight change. But so for weight and the scan traits in general, things haven't changed very much. I'm not saying that there won't be individual bulls who've moved a little bit, but it's basically because of their data, not because of any underlying genetic parameter change. When we come to reproduction traits, there are some bigger effects. First of all, we see the genetic trend for gestation length is not as big as we thought it was, and there's now a wider scale of EBVs, and so the bulls are going to be spread much further apart. There's a lot more scope for making change in gestation length than we previously thought. If people want to reduce it, we can reduce it a lot faster than we thought was the case. Now, the other consequence of that, I'll come back down to it in a moment. Scrotal, essentially no change. Days to calving, there's a very small reduction in the genetic trend, but not really very much. But this gets back to, I think it was your question, Lucinda, correlations between gestation length, birth weight and calving ease are important, and the simple effect of that is that bulls with higher birth weight EBVs are now penalised more in calving ease, and that's actually based on real Angus data. It was previously using what are called literature estimates, which is kind of taken from all over the world, and the truth of it was that the correlation that was being understood to be the case between particularly birth weight and calving ease, but also gestation length, was not as strong as is actually the case. But there are going to be some bulls that have moved quite a bit for calving ease, either because gestation length, they've proven to be not as good for that as we thought they were, or for birth weight, or a combination of the two. And there have been some bulls that have moved quite a bit, as I understand it, for calving ease. And it's largely because of this and this, the birth weight and the gestation length. But it does reflect the fact that we know a lot more about gestation length genetics in Angus cattle than we used to, and also this correlation between birth weight and calving ease we know much more precisely than we did previously. The carcass traits, the first thing I said was the heritabilities are all very similar, so we can make progress at pretty much the same sort of rates. The scales are increased, and that's because of the adjustment being from 300 to 400 kilos, and that's going to mean there's going to be a bigger range in bulls' EBVs for those traits than there used to be, and that will transfer, or that will carry over into their index values for any index that's got particularly marbling in it. So lots of bulls have been influenced by a big lot of data that's come in. I'll come back to this, and those bulls are going to be spread further apart for marbling than they were previously, and you're going to see that in their indexes because they've been spread something like 20 to 30% more than was previously the case, and it's because that scale has gone up. So These two areas are the places you'll see most differences in animals' EBVs. Firstly, bigger spread in gestation length and bigger movement in calving ease because of the correlations and also this gestation length, and bigger spread in the carcass trait EBVs than was previously the case. So let's say the range was plus or minus 5 for something, it'll be plus or minus 8 or 9 now, so bigger spread. Okay. I just want to quickly go through the few genetic trend pictures, really just to reinforce that by and large there hasn't been big changes when taken across the whole population. So just starting with 200-day weight, you'll see all these going to look very much the same by and large. There's a blue or a line of blue dotted things and a line of the black ones, and the blue one is the new one. Not quite. I squished the charts up, which is why there's not a little scale here. The blue one is the new one. You can see 200-day weight, the genetic trend in the Angus breed going back to 85, it's almost identical, and particularly in the last 10, 15 years, the changes in the breed plan analysis, there's no change in the genetic trend for that trait. Almost the same in 400-day weight. We see a bit more difference back 20, 30 years ago, but in recent years the trend is virtually identical. 600-day weight, absolutely no difference whatsoever. Mature cow weight, almost no difference. So what all this is saying is that the parameters that we've worked out in the big lot of new data in the last 10 or 12 years, they're not actually changing our underlying understanding of most traits by very much. It's confirming that they were already pretty good. If we look at carcass weight, same story, that's that one up there. Eye muscle area, the thing we realise here is we thought we made there was a bit more progress sort of from the 90s into the 2000s than is actually the case, but the trend in the recent years is essentially identical. So it's not changing the EBVs on average for eye muscle area.
That's what I'm saying is we potentially underestimated some of the older animals. Because
that's right.
Here on this side.
Yep, very good point. And a similar sort of thing with rib fat. The results are telling us that there were animals further back in time. This is this bit here. They weren't as fat. They were. Let me just get this right. They were fatter, that's the new trend, than we thought they were. So those older animals back here genetically were in fact this fat, not that fat. But in recent years, the EBVs are not changed at all. Intramuscular fat, same sort of thing. If you look at 2005's about there, and the two lines are in exactly the same place, and it's from here onwards is where there's been lots of data. All it's really telling us is what we thought about this period back to 1985 wasn't quite as accurate as we thought. And I personally think this is the period to concentrate on. If you're seeing big differences between this, that would have quite serious consequences for animals that have been, picked in recent years, and there's not much difference. Intramuscular fat, there's a bit more difference between the old, which is the old trend, and the new, and it really just says to me that what we now know about Angus cattle says their marbling, even back here, was a bit better than we thought it was genetically. So the marbling was a little bit higher back here than we thought, but the trend, particularly in recent years, has actually been pretty right, and that very similar. So people haven't been making mistakes in picking animals on IMF EBVs, particularly in recent years. Back here, people would have been underestimating the marbling on average, the genetic marbling of cattle back in this period of time. only two more of these. Carving ease direct. What this tells me is that the breed has not been doing quite as well for carving ease direct as was thought to be the case. This was the trend before. I'm sorry, I should have made these colours different. This is what we thought the trend was. So that's relatively small reduction. This is what we now think is the more accurate story, is a somewhat bigger reduction in carving ease, and moving in that direction is moving in the wrong direction. And I think that's almost entirely explicable by the fact that there's been an upward trend in birth weight, and that contributes to carving ease, and the gestation length. The thing we're seeing here is not such a useful trend in carving ease as we thought was the case. That's because we got better understanding of the relationship between birth weight and gestation length particularly, and carving ease, and the trends in those things have not been as favourable for carving ease as we thought they were. Carving ease in the daughters is a combination of direct and the maternal effect, and that's the old trend. So that was actually going upwards somewhat. What we now know is that went backwards a bit and has been improving, whatever that is, the last 10 years, roughly at the same rate as we previously thought, but it had got a bit worse before it started getting better than we previously thought. So it's really just saying that the trend is not quite what we thought it was, but it's going in the right direction now. Scrotal size, as I said before, there's virtually no change there, and you can see that the trends overlay each other. And days to calving overall is virtually unchanged in the trend. Then if we look at the four indexes we've got here, if we look first of all, I'll start with this one, although I know I'm not suggesting it's the most important, I just want to start with this one. There's virtually no change in the terminal index, and that's because there's been very little change in the trends for the weight traits and the live scan traits. This is basically weight and fat and muscle, and they're relatively similar to what we thought they were, and so the index trend looks almost identical. Now if we go to the other three indexes, and I will apologise in advance, I don't know the detailed makeup of these. I know general principles. Carl might have to help me if there are specific questions, but we can see that the new EBVs and indexes are telling us that the trend has not been, in the case of long-fed index, the trend has not been quite as big as we thought it was, and there was the cattle, whatever that was, 23 or 4 years ago, were actually better for that index than we thought they were at the time. As we get closer and closer to the present day, very similar values between the new evaluation and the old analysis. Similarly for heavy grass-fed, we're seeing that back in time, basically there was the cattle weren't quite as bad as we thought they were, or if you follow what I mean. We think now that they were better than we did before, and that's certainly the case with the short-fed domestic index. These cattle back here were genetically not as different from today's cattle as we previously thought they were. And that means the trend is not quite as big as we previously thought. So for that particular index, instead of, that's about 30, instead of sort of making $45, we thought we'd made something like $60 over that period of time. It's actually only about 45. So the trend's been reduced a bit, and I think the reasons for these differences in general are mainly to do with the differences in calving ease. So there's been the fact that there's been not quite as good trend in calving ease as we thought has pulled back the genetic trend in these three traits a little bit. The trend has not been quite as good as we thought it was, and the main contributor to that is that there's been not as much progress in calving ease as we thought. The main point of this was in general, to reinforce the thing I've said a couple of times, by and large, the technical changes have not been particularly big, except for a couple of traits, and one of the consequences of that is that we're not seeing big differences in the genetic trends. I mean, I shouldn't say big. They're significant, they're real, but they're not suddenly going in different directions. In this index, people were breeding for long fed, the direction of the index is up, the cattle are improving for it, it's just not quite as fast as we thought. And the same applies to each of these main indexes. The cattle are improving for the combination of traits that contribute to these indexes, just not quite as much as was previously thought. Now, I've only got a few slides left, I promise. I just want to comment briefly on the Carcass data because I think it's probably it's something that I'm sure your members have been thinking about quite a bit, and there's a couple of really important messages in it. The first thing I've said there, the data that was previously being used and that fed into the Angus breed plan up until this update was all coming from pre-2000. It was beef CRC data, and it was at carcass weight averaging under 300. There was no new carcass data came into the system in your breed or anywhere else basically until a couple of years ago, and it came in through a couple of the BIM type projects that are now underway. So essentially there was no new carcass data for that more than 10 years. The new data that's come in, and I'm sure you all know this, reflects somewhat different feeding systems. It's a longer feeding system than back in this period of time, and so the cattle that have come in through these projects have got average carcass weights of up around 400 or 400 kilos or more. So they're heavier than those animals that were used to do the work back in 2000. And one should rightly say, okay, well, what's that telling us? There's a couple of things that are really important. The first thing is, and that Gilbert and the team looked into this very carefully, the genetic correlation between these traits, in particular marbling, at a 300 kilo carcass and at a 400 kilo carcass is very high. And that's kind of an understatement. It's basically 1. The genetic correlation, the genetic control of marbling in a 300 kilo carcass and in a 400 kilo carcass animal is the same. It's the same genes, they're doing the same job, the spread is just a little bit bigger. So marbling at 300 kilos and marbling at 400 is essentially the same trait. It's really important to realise that. And that means that if you pick animals because of their EBV for carcass marbling now, you're not going to be picking animals that will not do the job at 300 kilos. The best marbling genetics based on measurements at 400 is the best marbling genetics for 300 kilo finishing. It's really important to understand that. That's a very, very important estimate, that genetic correlation. You see a bigger spread, and they may take longer to get there, and you might want to look for cattle that'll be faster to get to that point. But if you use data from 400 kilos to pick animals for their genetics for marbling, you'll be picking the ones that are good at 300 as well. It's really important. And because of that, the correlation between the EBVs, the carcass EBVs in the old analysis and the new is extremely high, and that goes for all of them, not just marbling. They're all up over 90%. If you look at the carcass EBVs for animals from whatever it was, the March run, and you correlate it against the analysis that's just been completed, the correlations between the older EBVs and the new ones are very high, and the ranking is very highly correlated as well. It's really, really important message. The second important point to make about this is this change in the endpoint is simply in how the data is analysed to produce the EBV. It's not causing a change in the trait in the dollar index. The dollar index is for a 300 kilo production system. It's a 300 kilo EBV that is actually used in the calculation. You may not see that reported. What you see reported is Carcass IMF at 400 kilos, but what's going into the index is the actual endpoint for that production system. And so if, for instance, the domestic, what's it called, short-fed domestic index is based on a 300 kilo carcass, the marbling trait, if it's involved there, the marbling trait is for 300 kilo carcasses. So this change from 300 to 400 kilo endpoint does not change the way the information is fed into the dollar indexes. That's the first important point in this slide. But there is a big impact of this carcass data. There is no question about it, and many people have seen it. And the reason for that is because we've now got actual direct carcass data, not the scan. This, getting back to your point, Sam, and I'm just about to work through it. This is a really profound change in the Angus analysis. Remember I said in the previous slide, there was no new carcass data since 2000 until about a year or so ago, and now we've got a big hit of actual carcass data has come in. So all the bulls that have got progeny in the bins and the supply chains that are collecting carcass data, that's added lots and lots of information about their genetics to the Angus Breedplan analysis, and those bulls are going to move quite a bit because they've got actual carcass data. It's not relying on the correlation with scan. And this is really, really valuable for the breed because it's making the carcass EBVs are more accurate now because there's direct carcass data in there. Scan is good, direct carcass is much better. And I'll just, yes, I've got a little, what I hope is a nice graph to talk about this, and this comes back to your point, Sam. The correlation between, the genetic correlation between, this is marbling I'm talking about, but in general it applies to the other fat traits. The correlation between scan marbling and actual carcass marbling, the genetic correlation is 0.6. So scan is not a perfect measure of carcass marbling genes. It's a good guide, but it's not the same as having direct carcass marbling. And what I've done here is work out the accuracy of, if we were conducting progeny tests for carcass marbling, so we're trying to find the animals with the best genes for carcass marbling, and we're either using direct carcass records or scan records on various numbers of progeny. And all I've done is work out for various numbers of progeny how accurate would the bull's EBVs be based on that data. Okay, we've just been talking about the fact that we're now bringing in direct carcass measurement for a number of animals. Well, we've got progeny from a number of animals, and that means for carcass traits like marbling, at least some of the bulls in the runs now have direct information on their progeny, either in addition to or it's new, rather than just relying on the scan carcass correlation. And I just want to spend a minute or two explaining the effect that that has in terms of accuracy of EBVs for carcass marbling itself. And we've got a chart here which shows how the accuracy of a progeny test varies according to two things. First of all, the number of progeny, which is the axis across the bottom. So you can see we've plotted this from going from 0 progeny to 100 progeny. And the vertical axis, the vertical scale, is the accuracy of a progeny test, and you can see it goes from 0 to 100%. There's the accuracy of a progeny test EBV, and the trait we're trying to get the EBV for is carcass marbling. And we've got two ways of doing it reflected in this chart. Either using direct carcass measurements on progeny of the bulls, and that's the solid blue line, or using scan records on the progeny of the bulls, and that's the dotted line. Now you can see that the solid line, which is direct carcass measurements, is much it's higher accuracy all the way through the scale than the accuracy resulting from use of scanning records. And the reason for that is, remember, we're trying to get an EBV here for carcass marbling itself, and we've either got the direct measure on the progeny or we've got scan records, and the genetic correlation between those two traits is only modest. It's about 0.6 in heifers and less than that in bulls. And because of that, the scan data doesn't give as much information about the animal's genes for carcass marbling as does directly measuring the carcasses. And accordingly, the accuracy of the progeny test is significantly higher if you've got direct carcass measurements than if you're relying on scan. The note in the box there says at the bottom, 7 effective carcass records give the same accuracy as 10,000 scan records. That's a bit daunting, it's a bit surprising, but it's simply a function of the fact that you're looking directly at the trait you're interested in, which in this case is carcass marbling, rather than looking at it indirectly through a correlated trait, the correlated trait being scanning. So the fundamental point here is that direct measures for the traits you're interested in are always going to be more useful, more accurate than indirect measures. Scanning is useful, but it's only up to a point. It's got limited usefulness if we're interested in carcass marbling. The accuracy of progeny test EBV using scan, the accuracy of the EBV resulting, if you're looking at for carcass marbling genetics, it can never get above 60%, and that's a function of the correlation between the two traits. So the really important point there is, if you're interested in a carcass trait to be breeding for, carcass marbling for instance, and obviously that's what the consumer experiences, you are much better off if you can get direct measures for it and use those in the breed plan analysis than scan records. Scan records are useful, but direct measurements are much more useful. Nowhere near as interesting, I can promise you this. Very quickly, shear force is one of the traits that was being researched in the CRC, and it's of interest because it's related to tenderness. I think at some point there were tenderness or shear force EBVs may have been produced for some Angus cattle. They're not now. The heritability has been found to be 0. There are no genetic differences that can be detected for shear force in Angus cattle. Now, in some ways that sort of doesn't surprise me much because the big thing is that Angus cattle don't have the toughness genes that float around in some other populations, particularly Bos indicus. So it's kind of saying, generally speaking, Angus cattle are quite reasonable for shear force, but there's no genetic differences left there. It also, stepping sideways, says you should be very dubious about someone selling you any sort of test to pick up tenderness differences in Angus cattle, because there aren't any. Moving on, just very quickly about NFI. So Gilbert and the team estimated the genetic parameters for net feed intake in recent Angus data. That was very helpful, and the heritabilities have been found to be 0.4, 40%, 35% for the early and late feeding periods. But more importantly, they also estimated, worked out the correlations particularly between fatness and muscling and feed efficiency. Previously those correlations weren't included in the model, and they are now, and so the EBVs for NFI are going to be more accurate than they were previously. They were only trial or research, I think, and they weren't available. Now they're actually using current Angus genetic parameters, and they're taking account of these correlations with fatness and muscling. And so there'll certainly be some movement on animals that used to. Just briefly, not a lot to say about this, but part of the work was to check the adjustment factors, which are part of the calculation of EBVs. It's taking account of things like the time of the year when the calf was born, how old the calf's mother was, what sex it is, etc., etc. This is by no means the full list of them, but an exhaustive analysis and re-estimation of the adjustment factors. Most of them relatively small changes, but just a couple of examples. Season of calving is handled more accurately now than it was, and there are different adjustments for the two sexes within the birth seasons, whereas previously there weren't. And there's a slightly smaller adjustment upwards for older cows' records in days to calving. So there's a few things of that nature. I don't have a detailed list of them. The net effect is just to take account of that, those adjustments a little bit more accurately than was previously the case. But I don't have anything else to add on that one.
Thank you.
I think we've talked about this, but just to reinforce the point that the Angus Breedplan analysis certainly includes genomic tests. The work on genomic tests is completely separate from what I've been talking about so far, so I'm not really going to say much about it. But you can handle, Angus Breedplan can now take in information from either Zoetis or Agenity or beef CRC prediction equations when they're available. We've done the calibrations on them to test them against the corresponding Breedplan traits, and the accuracies from that are what are used to blend into Angus EBVs in Angus Breedplan, and the accuracies for all the tests, broadly speaking, in Angus are what I'd call moderate, and they're typically similar to or a little bit below the estimates that are published by the commercial companies. But the accuracies have been calculated for how those tests work in your cattle using Australian Angus data. And that's now part of Breedplan. I'm not sure I should even put this slide up.
No, I think it's worthwhile to just quickly step through that.
Okay.
And then we will.
So this is work in progress. So I've been talking about in the main the work that's been done to for the calculations for EBVs in Angus Breedplan. This is a few points of work that is coming up or we've started on that we'll be communicating with you about over the coming months. There's been some interest in stability or cow longevity kind of EBVs, and scientists in AGBU have had a look at this, some people in the United States as well, and we're now working through the process to generate some EBVs for Australian Angus cattle for this trait. It's basically how long do you expect cows to stay in the herd, independent of things like their genetics for marbling or days to calving, etc. It's like, after taking account of all those other things, how likely are they to stay there, and in discussions with Peter and Carl about when we might be able to do that work and produce some results, but that's likely to be fairly soon. Steve Barwick is working on index upgrades, and will be working with Carl and Peter and you people to include in the Angus indexes cow longevity, cow condition score. There's a couple of other traits. So an upgrade to indexes is coming soon, and is going to include some traits that haven't been in the indexes before, but which now can be included because we know the parameters for them. This is moving away from the sort of stuff I've been talking about so far, but we're doing the work on taking Breedplan from its current version to using what's called single-step analysis, where basically you include genotype information or DNA information at the same time as putting in pedigree or phenotype. Currently we bring it in 2 steps, and we're going to replace that with what's called a single-step method, and that will allow you to just feed in genotypes as they come in alongside all the other records. It'll be more streamlined. We're just starting to do some work on trying to understand the value of the data that's contributed by people and that comes from different sources. So how valuable is it to have 500 records on a particular trait or 300 on some different combination, to get a feel for the how much power it's giving the analysis. It's going to help people optimise how much recording and genotyping they do, and also help people plan things like bin projects. Is how much is it worth spending on, 2,000 records or 4,000 records or 50 records, that sort of thing. slightly more blue sky. We and other groups in Australia and overseas are looking at the use of the actual DNA sequence of animals rather than a series of markers, which is what the chip tests are at the moment. It's now possible to get the actual DNA sequence of cattle. It costs, I think it's about $1,000 or $1,500 an animal at the moment, but it'll be cheaper in a couple of years' time. There's quite a number of ways that might be useful. One is to actually find animals that are carrying undesirable conditions much more quickly, but it may also help with more accurate EBVs and reducing the need for phenotypes a bit. We're also looking at what would be involved in, instead of going to monthly breed plan runs, for instance for Angus, in principle just doing it every day. So whatever new data came in today comes in, and tomorrow morning there'll be updated EBVs for those animals available. That might sound kind of implausible or unbelievable, but it's technically quite feasible, and there may be some advantages in doing it. So that's some of the more researchy type things that we're working on. And to finish off, I hope what I've said has made sense. There's been a couple of points where I know I've got to follow up and provide some correction or some further information. The general message I want to really reinforce is Gilbert and the team have used a very, very big amount of recent data to make sure that the parameters that are being used to drive Angus breed plan are accurate, and accordingly that EBVs are as accurate as we can possibly make them. And the general message is the EBVs you were getting before from the old analysis were good, they are now better, and in 2 or 3 traits they're significantly better, significantly more accurate, particularly calving ease, and that carcass data is really important. I took you through all those genetic trends, and that really just tells us that the relativity between animals, particularly across time, is little changed for most traits. So if you think you've got an animal today that's 100 kilos better for, say, a growth trait than an animal from 10 years ago, the new analysis will tell it'll still be 100. The base might have shifted a bit, have been moved, but the difference is still about 100. And that applies to essentially all traits. So the differences between animals today and differences 2, 3, 4, 5 years ago are consistent with what they were. And the point about the carcass data is really important because it just highlights the value of direct data, especially for hard to measure traits. And that's part of the reason for the progeny test project, is to start to collect data on the traits themselves that make money rather than using indicator traits. That's all I had, Mr. Chairman. I hope it's been helpful.
Thank you. Thanks, Rob.